So this is going to be the second lesson that we've done where we've done some congruence theorem. Well, actually, we did postulates before. What's the difference between a postulate and a theorem? I've asked you this 100 times. You should know the difference. A postulate is what? Right, it cannot be proven. Very good. Okay, it's just accepted as fact. You can't prove it. But a theorem, what can you do with a theorem?
You can prove it.
You can prove it. That's right. Is this lesson postulate or theorem? Yeah. Oh, I see what they're doing. Okay. So, come on, settle down, please. Let's do this. Let's draw a couple triangles. Again, there doesn't have to be anything special about these triangles. I'm just going to draw it like this. All right. Of course you should be copying this. These are notes. Notes basically are just copying what the teacher writes. That's okay. It doesn't matter. All right, so here's another congruent. This is not a postulate. This is actually a theorem. Okay, this is actually a theorem, so it can be proven. I'm not really going to go through why, but I don't know. Maybe we will. So let's do this. Let's call this ABC. Let's call it DEF. All right, now here's some stuff that they give you. Now, right now, just looking at them, can I say for a fact that they're both congruent right now just with the information they've given us? No, they haven't given us any information, have they? They haven't told us anything about any angles being equal, any sides being equal, nothing. So I can't say. You might look at it and say, well, they sure look like they are. And I saw Mr. Hamrick hit Control-C, Control-V. So yeah, they must be, all right? But that doesn't mean, okay, well, actually, Control-C, Control-V does mean that they're congruent to each other. But let's say you didn't know that. There's no way you can tell that those are congruent to each other. But what if they gave you some information? So what if they said that this angle, I want to change colors. What if they said that this angle and this angle were equal to each other? Okay. And this angle and this one right here were equal to each other. And they tell you one more thing, all right? They tell you that this side and this side are equal to each other. Isn't that the same as what we just did before in the other lesson? Isn't this just angle, side, angle? Think about it. Why not, Cabri? It's not in between it. Very good. It's not the what side? Included. Right. It's not the included side. Look, I've got an angle and an angle, but look at this side right here. The side is not in between. If the side was in between, so if AB and DE were equal to each other, then these triangles would be congruent because of what reason? Angle what? Side angle. But this side is a non-included side. Everybody hear me? Non-included, which means it's what? It's not in between. It's not included. Everybody got that? It's pretty easy. This is enough. What is what? This is DEF. I know. Look, that's a C. I read it, okay? My writing's sloppy. I agree. But this is ABC. This is DEF, okay? I said it when I put them down. Okay. I've seen it. All right? So here we go. So this is not congruent because of angle, side, angle. But watch this. This is kind of a proof. We actually talked about this, was it yesterday maybe, or the day before? I can't remember. I can't remember. But anyway, watch this. If I have two angles of one triangle equaling two angles of another triangle, what must be true about the third angle? They got to be equal to each other, all right? Because I'm taking the same things away from 180. So this plus this is the same as this plus this. Everybody got it? So A plus B, angle A and angle B add up to be whatever number. I don't know what it is. I don't know what the degrees are, okay? But they add up to be a certain number. Then look here. I'm adding up the same two angles, right? Everybody see it? Because these two are equal to these two. So if I take the same thing away from 180, I'm going to be left with the same thing. Do you hear what I just said? All right, so I'm taking these two away from 180, and I'm taking the same two things away from 180. So what must be true about what's left over? These have got to be what to each other? They got to be equal to each other, okay? There is a theorem that talks about that. I don't know if we've actually done that one yet. But anyway, I think we may have. I just can't remember. I don't know. I teach this to 3 different classes, and I'm in 3 different chapters, and I can't remember what I said from one class to the other. So check this out, though. Since I know that angle C and angle F are equal, look what I have. I've got an angle and a what? A side and another angle, right? So really, these are congruent because of what? Angle, side, angle. Everybody see that? So let's get rid of this and this, even though we know that they are going to be equal to each other. Now watch this. What if this is the only information that's given? Could I say that these triangles are congruent to each other?
Yes.
I can, because I just went through and I said that angle C must be equal to angle F, because that whole take away from 180 thing. And then I've got angle, side, angle. But that's not what I was given originally, was it? I wasn't given this angle and this angle. So just from the information that we've been given, I can now say that this triangle is congruent to this triangle. What do you think the theorem is? It's not going to be side, angle, side. It's not going to be angle, side, angle. What do you think it's going to be?
Side, side, angle.
There's 2 sides? There's only one side. There's only one side. It's not angle, side, angle, because the side's not in between. It's angle, angle, side, okay? So we call this the angle, angle, side. Now this is a theorem because we actually proved it, okay? By doing that whole 180 thing and saying that they're congruent because of angle, side, angle, that kind of proved that this is enough information. This is enough information to say that those triangles are congruent to each other, okay? I could have also done this. I could have said, watch, what if I said that this side was equal to this side? Is that good enough to say that these triangles are congruent?
Yes.
Absolutely. And what's the reason? It's angle. It's quit saying side, side. There's only one side on this triangle, okay? So there's an angle, there's another angle, and there's a side. The side is not included, right? So why are these triangles congruent? Because of angle, angle, side, all right? What if I told you that this side was equal to that side? Now, why are these triangles congruent now? Angle, side, angle. Angle, side, angle. All right, so the reason why the triangles are congruent could be for different reasons. Even though I'm given 2 angles in one side, it all depends on where that side is. So let's go back to the original one. I think it was this one, right? So look, if I asked you why those triangles are congruent, you would tell me why. Angle, angle, side. Now, what if I asked you to write the congruence statement? This is pretty easy because I didn't flip anything around. I didn't twist anything. All right, it's pretty simple to see which triangles are congruent. So here's a possible question. I could say, write a congruency statement. What does that mean? Write a congruency statement. It means tell me which triangles are congruent. So what do I want to call this one right here? ABC? All right, that's probably the easiest way. Is congruent to what? No, it's triangle. Okay, make sure you put the triangle symbol. So triangle ABC is congruent. Which one over here matches up with A? The D, because that's got one arc and that's got one arc, so that's D. All right. Which one matches up with the B over here? E. Why? Because it's got the 2. All right, so that would be the E. And then, of course, what's left over? The F. So this would be your triangle congruency statement. All right, let's write that word down. I say it, but I want to write it down. So it's going to ask you to write a triangle congruency, I think I spelled that right, statement. I was going to write theorem, but statement. All right, this right here in the box, that is a triangle congruency statement. So that could be on a quiz or a test. Everybody hear me? It was on the homework, right? We've had a homework where we asked that. We spent all class period yesterday going over that homework, all right, and writing the congruency statement. What if, before we move on to something else, what if, let me do this. Let me get rid of this just so I have some room to write. What if instead of calling it triangle ABC, I call it something else? So what else could I call it?
EDF.
Let's go different than just going backwards. BCA. All right, let's do it like that. BCA. We kind of mixed them up a little bit like that. All right, now look. The second triangle has got to match up with the first one. So I could call it triangle BCA. Do I have to call it triangle ABC? No. Okay, I could call it BCA. So if I go BCA, I'm going from what? From 2 arcs to no arcs to what? To 1 arc. All right? So I'm going 2, none, 1. What do I do over here? 2 has got an E, then none is the F, and then the 1 is the D. So this would be a triangle congruency statement as well. Either one of these would be acceptable. So if I asked you to write a triangle congruency statement with those 2 triangles, either one of those would be fine. You're looking at this, you're like, well, that looks different than that. It doesn't look the same. But look, the B and the E match up, and the B and the E match up here. The A and the D match up here, and the A and the D match up here. Okay? Everybody see that? Right, they got to match up though. That's the thing. What if we did this? What if I said that? Would I give that to you? Would I mark that right? If you said that BCA is congruent to DEF.
You should, because the lines don't match up.
They don't match up. That's right. The B and the D, look, the B and the D don't match up. This one has 2 arcs, that one has 1 arc. They don't match up. That right there by itself means that I would mark that wrong. So if you wrote this for a triangle congruency statement, I would mark it wrong. Okay? If you wrote that, I would mark it right. Everybody got it? And there's a bunch of different ways that you could mix them up, and they could be right. So there's not just one way. All right? But you could get it wrong, even though you use the same letters if they're not in the right order. If the B and the E don't match up, if the A and the B don't match up, and the C and the F don't match up, then the triangle congruency statement doesn't work. Everybody got it?
Yes.
All right. Because the reason I'm harping on this is because so many times people's like, well, I just got it in the wrong order. Come on, what's wrong with that? What's up, Mr. Hamrick? You know, I'm like, well, I told you. It's exactly right. You remember that, right? All right, so let's move on to something else. All right? I think we got that. That's the only other theorem we're going to do today. We're going to do some more in another lesson. Let's talk about this. You probably know this word already. What am I going to write? Isosceles. Have you learned how to spell it yet?
Yeah,
Isos and then celes, C-E-L-E-S. Okay. So make sure you spell it correctly. All right. So here's what's called the isosceles. What's that symbol?
Triangle.
Triangle what?
Theorem.
Right. It's just my shorthand way of writing theorem. Okay. So here's the isosceles triangle theorem. Let me tell you what. I can use this thing. And let's make that 3 sides. There we go. And I'm going to make it look like that. All right. Is there anything I can say about this triangle? Do I know this is isosceles just yet?
No.
No, I don't. There's nothing I can say about it right now because nothing's given. But what if I did this? What if I told you that that segment was equal to that segment? Now, what can you say about that triangle? Now you can say it's a what kind of a triangle?
Isosceles.
Isosceles. Why? Because
It's isosceles.
2 sides are equal to each other, right? Okay, at least 2 sides are equal, but we always just basically, if 2 sides are equal, then it's isosceles. All right, so that's an isosceles triangle. Here's what the theorem says. We have the isosceles triangle theorem, and then we have the converse. The converse means we just switch the if and the then. So this says, if you have an isosceles, I'll just shorten that, triangle, then, I have to put the word in there, comma, then something else is true. So if this is an isosceles triangle, and is it isosceles? Yes, it is. So if it's isosceles, what must be true about it? Well, I'll show you. The theorem says this: the opposite angles must be equal to each other. So if you have 2 sides that are equal to each other, the sides that are opposite are also, the angles that are opposite those sides are going to be equal to each other. So just by knowing those two sides are equal, I can tell you something about two of the angles. What could I tell you? What do you think? Which ones?
A and C.
A and C. Are they opposite? Are A and C both opposite? No, it's not A and C. What is it? It's B and C, because look, B is opposite that side, and C is opposite that side. So what does the theorem say? I read it to you. I didn't write it down yet, but I said if you have an isosceles triangle, then the opposite angles are what? Are equal to each other. So the angles that are opposite those two equal sides are now equal to each other. And that's what our theorem says. I'm not going to go through a proof or anything. It is a theorem, so we can prove it, but I'm not going to prove it in here. All right. Let me get rid of all this mess so it looks a little nicer. Everybody with me on that? The opposite angles would be equal to each other. The angles that are opposite the two equal sides. Okay? Let's put this right here. Let's call this DEF. All right. Now, this, the red is what they give you, okay? So this time they give you a triangle. They don't tell you it's isosceles, but they give you a triangle and they tell you that angle E is equal to angle F. Do you see the difference between the two? What did they give you on this one?
The angles.
No. What did they give you on this? Not the angles, the what? The sides. So I could say they gave you what? That AB was equal to what? AC. That's what they told you to begin with. That's right. So on this one, what did they give you on this one? That angle what? Well, not just EF. Angle E is what? Yeah, we're not going to write the same as. What are we going to write? Equals. Right. Equals what? Angle F. Okay? So this is what they give you. Everybody understand that? Whoops. Wrong button. So what do you think might be true? What do you think else might be true about this triangle then? They told you that this angle and this angle were equal to each other. So what do you think that means about a couple of the sides?
Equal.
What are equal?
Two sides.
Give me the names of them. Don't say D and E. Just say DE, DE, and what? D what? I already said DE. DF. That's right. All right. So watch. If you have an isosceles triangle, then the opposite angles are equal. Okay, that's this theorem right there. So if it's isosceles, which means what? Two sides are equal, right? So they told you that these two sides were equal. Then what do you know about the angles? Then you know the angles are equal. Do you see the difference in these two? This time, they don't tell you anything about the sides. They tell you that the two angles are equal. So what does that mean about the two sides then? Then the two sides are equal. So what does this say? If the opposite, I should say this. Let's say this. If two angles are equal in a triangle, right, then the what? The opposite sides are going to be what? Are going to be equal to each other, okay? Do you see how it's kind of like the inverse of this? It's actually called the converse, right? So that theorem is with this triangle. So this one, what did they tell you? They told you the two sides were equal. What could we figure out? We could figure out that the two opposite angles are equal. Okay, that's what we know about it from this theorem. What does the second theorem give you? The second theorem gives you that the angles are equal. So what can we figure out about the two sides? The two opposite sides are going to be equal to each other. Okay, let's do a quick little example. And then we'll do one more thing and we'll be done. When are we out of here? Is it quarter after? Yep. Quarter after.
I think it's the quarter.
Do you know quarter after?
Yeah,
What does that mean?
25 is a quarter. So
Is it?
No, dude, he just told us
So
last.
after, so 15. So
25 is not a quarter of an hour. 25 is not a quarter of an hour. 15 is a quarter of an hour. 25 is a quarter of what?
An hour.
No. 25. 100, right. It's 100, like $1, right? That's why we call those coins quarters. Did you know that? All right, we call them quarters because it's a what? A quarter of a dollar, which is 100. What's a quarter of an hour?
60.
Okay.
Are you doing this on purpose? Are you seriously? Are you saying that stuff on purpose?
We don't gotta go over this.
Because you're really scaring me.
Because he's scaring me too much.
What's a quarter of an hour? A quarter of an hour is 15. That's right. So when I say quarter after, that means 15 after, or 11, what? 15. Okay. See, I'm teaching you all kinds of good stuff here. What was I going to do? I was going to do something. Oh, yeah, let's do an example real quick. Okay. Yes, you do. All right, let's everybody look here. Okay. Shh. Let's pay attention. All right, here we go. What if I told you that this was 5 and this was 5, and I told you that this was 40 degrees? Okay? So that's the information I gave you. But I want you to find this angle right here. We'll call this X, Y, Z. All right? So what is that angle going to equal? Try it. Do it in your notes. I'll give you a second to think about it. I don't want to hold your hand through this whole entire thing. I want you to think a little bit.
Like 80.
Like? I don't want like. I want exactly.
80.
What'd you say? Come on, let's think. You're not thinking. You're just talking.
Probably like one side.
Evan, let's think. You're not even trying.
The X angle?
I want the X angle. Right. This is what I want to find. I want to find that angle right there. That's 40?
No, it's 160.
How'd you get 100? Okay, look.
Wait.
Look right here.
Because they all add up to 180, and then the other side is going to be 40.
You got
That
it.
means the top is going to be 100.
That's right. You got it. Okay. So look, if this is 40, shh. Why did I say that was 5 and that was 5? What did that have to do with anything?
Because they're two sides equal.
It means that if the two sides are equal, then these two opposite angles are equal, okay? If I didn't know that those two sides were equal, I couldn't find this, okay? If I just knew one angle, and that's all I knew, I couldn't find the third angle, okay? But I do know that this side, or this angle and this angle are equal to each other. Why? Because the two sides are equal, okay? If the two sides are equal, then the two opposite angles are equal. So that must mean this is 40 right here. Now, how do I find the third angle? Add these up, right? So 40 plus 40, which is what? 80. And then how do I find the missing angle? I take it away from 180, and that gives me 100. And so that angle right there is 100 degrees. Okay? That's the kind of stuff that they're going to ask you, all right? And you have to know that triangle, isosceles triangle theorem, right? If the two sides are equal, the two opposite angles are equal, okay? They could just ask you to find that angle. That'd be super easy, wouldn't it? All right? I just made it a little tougher having you find the third angle. But I could ask you to find this one, or I could ask you to find that one, or I could ask you to find both of them. All right, enough of that. Let's do one more. Let's draw a triangle, and I'm going to make it equilateral. What does that mean? What does it mean to be equilateral? All the sides are equal, okay? So all three sides are equal to each other. All right, so watch this. And we're going to do a little bit of a proof. It's not going to be a formal proof, but we're going to think through it a little bit. So watch. This side and this side and this side are equal to each other. I'll call this P, Q, R. Okay? So it's an equilateral triangle. That's given. It's in red, right? I've usually been making my red the given part. And I'll put the others to yellow. So check this out. If these two, and this is the proof, okay? We're kind of proving this. This is the theorem, all right? And we're kind of proving it right here. So if these two sides are equal, which they are, aren't they? So what does that tell me about P and R? Then they're equal to each other, okay? Now watch this. Watch very carefully here. If this side, PQ, and PR are equal to each other, then that means the opposite angles are equal as well, right? So this angle is opposite that side. This angle is opposite this side. So they're opposite the same angles that these two angles were, or the same sides that these were. I can't even talk. These, I don't know. So that's going to be equal as well. Everybody see that? Because look, if these two sides are equal to each other, okay, then the opposite angles are going to be equal, which means this one and this one are equal. So if that already had one arc on it, then that's got one arc on it, okay? If these two are equal, then these two angles right here are equal. If these two sides are equal, then these two angles are equal. You see that? So here's what our theorem says. Our theorem says if you have an equilateral triangle, it must also be what? What's the word? We used this word before. Equal what? Angular. Right, angular. And that's basically what your theorem says. It goes both ways. All right, I'll put an arrow right here. So arrows go both ways. So if it's equilateral, if all the sides are equal, what's true about all the angles? They're all equal. What if they told you all the angles were equal? What could you say about all the sides? Then all the sides are equal to each other as well. Okay? It goes both ways. So if they told you that all three sides are equal, I know that angles P, Q, and R are equal. Okay? I'm not going to redraw the triangle, but what if they told me that P, Q, and R were equal to each other? Angles P, Q, and R. What would be true about the sides? The sides must be equal. Okay? So if it's equilateral, then it's equiangular. Or you could go the other way. If it's equiangular, then it must also be what? Equilateral. Okay? With that said, I think we might have done this before. I can't remember, but let's do it now. How many degrees this is the information I've given you. I'm not going to give you any other angles, but how many degrees is that angle right there? That one angle is 180 degrees. Come on, think before you talk. 90?
60. It's less than 90.
Why 60? Somebody give me a reason. Taneg, you said it quick. Give me a reason. Exactly right. I love that. It's 180 divided by 3. How did you know to divide by 3? Because what's true about all three angles? They're all exactly the same. That's why I can divide by 3, because I'm dividing equally, correct? Right? So how many degrees are all three of those angles? Okay. Well, all three, all added up. 180 degrees. Okay. And if they're all exactly the same, what can I do? I can divide it by 3, which is what? 60 degrees. So every single equiangular triangle, what are the degrees? What are each of the angles in that triangle? 60 degrees each. Okay. What if I told you it's an equilateral triangle? Same thing. Exactly. Then they're going to be equal as well. Let me do one more thing and we'll quit. Okay. This is a great way. I love that she said 180 divided by 3, but let's do it algebraically. All right. Let's call this angle, let's not call it question mark, and let's not put an arrow there. Let's call it angle X. I'll just put X degrees. That's X degrees. All right. So how many degrees is this angle right here then? No, if this is X degrees, then this is what? It's the same thing, X degrees, right? And what's this? That's X degrees. So what can I do with all three of those angles? Add them up. So I'm just going to do this algebraically just to show you that it comes out to be the same exact thing as what we did up here. Okay. This definitely was a little easier, but I'm going to show you. So this X plus this X plus this X, all three must add up to what? 180. Let's do a little math. What's 1X plus 1X plus 1X? That's 3X, and that equals 180. Okay? I'm just doing this algebraically. Now, what can I do to get X by itself? Divide by what? 3. Divide this by 3. Do you notice? We're doing the same thing. All right? I'm just kind of showing you algebra-wise how this works out. So the 3's cancel. X is 180 divided by 3, which is 60. So each angle is 60 degrees. So that's kind of like a little proof of that as well. All right? So we only learned one congruence theorem, but we learned some things about isosceles triangles. We learned about the sides. We learned about the angles and all that stuff. It's really important because we're going to use this. All this stuff, every little bit of thing that we learn, we're going to use it to be able to solve for problems. Eventually, you're going to have a problem where you're going to use like 5 or 6 different things that we have learned in the past. All right? So that's why we're learning. We learn them just a little bit at a time so that you aren't overwhelmed with it. But you got to learn it. It's a building block. It's a foundational thing. All right? You're going to use this stuff over and over again. In fact, I think in my honors class, we're in chapter 7 now, I think. And we just did something where they had to look back to something a long time ago, right? It's like, hey, do you remember doing that stuff? We're going to apply it again. So just because it was in a chapter a long time ago doesn't mean we forget about it. That's what math is. Math builds and builds and builds. So if we learned something a long time ago, I'm telling you what, it's going to come back and we're going to use it again. All right, so let's make sure that we know how to do all these things. Any questions on this? All right. Well, you got 1 minute left, so just stay in your seats. No standing up, no walking around. Just wait until the bell rings. 2 minutes left then. That clock's a little fast.